Hello, dear students. Today we have chapter number 4, Chemical Foundations, Elements, Atoms, and Ions. We know until this moment 118 elements. 88 are in the environment in a natural way. The rest have been made in laboratories. The abundance changes a lot from one to another. I can tell you that 9 of these elements made 98% of the total mass of the Earth. These elements are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, and hydrogen. All of them uh, are important parts of the planet. Only silicon and oxygen are combined, making the, the silicon dioxide that is the sand that is all over this planet. Well, the elements can be written for the first letter of the name or the first two letters. Always the second letter is with lowercase and the first one with capital letter. Some of the names of the elements come from Greek. For example, gold, we don't write G or GO, we write AU because come from this word that is from the Greek language. Same thing happened with lead. The symbol is PB because it comes from plumber. That is the name of this element in Greek. Okay, something that is very, very important is to notice the way we represent the symbol of every element. It is very important to write always the first letter with capital and the second one with lower case. Most of the material are mixtures of pure substances. Remember that a pure substance could be an element or combinations of elements. But the compounds always contains the same proportion by mass of the elements. The law of constant composition says a given compound always has the same composition regardless of where it comes from. For example, water always contains 8 grams of oxygen for every 1 gram of hydrogen. Carbon dioxide always contains 2.7 grams of oxygen for every 1 gram of carbon. Dalton was the first, let me tell you, scientific theory that explained the composition of the compounds, and maybe explain all the elements and the particles that are in the environment. He says that elements are made of tiny particles called atoms. So he called atoms to the elements. all atoms of a given element are identical. The atoms of a given element are different from those of any other element. And also said, atoms of one element can combine with atoms of other elements to form compounds. A given compound always has the same relative number of types of atoms. For example, nitrogen monoxide has one nitrogen atom and one oxygen atom. Nitrogen dioxide contains 2 atoms of oxygen per 1 atom of nitrogen, and so on. The Dalton's atomic theory also says that atoms are indivisible in chemical processes. Then you cannot break into pieces an atom. It's the most simple unit of matter. Atoms are not created or destroyed in chemical reactions. A chemical reaction simply changes the way the atoms are grouped together. Here you have a question. You can stop the video at any time and you can answer it. Chemical formulas describe the compound. What is a compound? It's a distinct substance that is composed of atoms of 2 or more elements and always contains exactly the same relative masses of those elements. What is a chemical formula? Well, express the types of atoms and the number of each type in each unit or molecule of a given compound, of course. For example, here we can see that SO3. S is the symbol for sulfur. O is the symbol for oxygen. But you can see here, you don't write the number 1, but you know that here you have only 1 atom of oxygen, and here you have 3 atoms of oxygen. Then the number of atoms in a compound is constant. Here we have a formula. This is a formula for DDT. It contains 14 carbon, 9 atoms of hydrogen, and 5 atoms of chlorine. Thomson showed that atoms can be made to emit tiny negative particles. He discovered the electrons. The negative particles in an atom are known as electrons. He also said that the atom has a positive particles that balance exactly the negative charge carried by electrons, so that atoms have a 0 overall charge. William Thomson explained a model of the atom this way. He said, here you can see a plum pudding. Well, his model is known as pudding. Why? Because it says that the mass of the atom is made of positive charge. And he says that in this mass of positive charge, you can find the tiny particles known as electrons that have the negative charge. Then the model of William Thomson about the atom is known as plum pudding model. Rutherford in 1911 conducting an experiment on alpha particle bombardment of a metal foil. Well, he concluded that the result from the Planck coding model is wrong. The, the atom has a dense center of positive charge called the nucleus, and the electrons travel around the nucleus at a relative large distance. Then, look at this. You can say that most nuclei also contain a neutron particle called the neutron. This was discovered in 1932 by Rutherford and Chadwick. An electron is slightly more massive than a proton but has no charge. Then the proton is positive, the electron is negative, but the neutron is neutral, not positive nor negative. The atom contains electrons, negative, that are around the nucleus. Protons and neutrons that are in the nucleus. Protons are positive and neutrons are neutral. Then you can see that the electrons have a relative mass of 1, while a proton and a neutron has 1,836 and 39 a relative mass. As you can see, the mass of the atom is in the nucleus because the mass of the electrons around the nucleus is too small compared with the mass of the proton and the neutron. The charge of the electron is -1, the proton is +1, and the neutron has no charge. Okay? Then, why do different atoms have different chemical properties? The chemistry of an atom arises from its electrons. Electrons are parts of atoms that are combined while we are making a molecule. Then, in chemistry, the electrons, and in special the ones that are in the outer shell, are the most important because they are the valence electrons and are the ones that take part of the chemical reaction. Isotopes are atoms with the same number of protons but different number of neutrons. Remember that, same number of protons but different number of neutrons. Show almost identical chemical properties, okay? Because the chemical properties depends on what? On the electrons. Then no matter if you have more or less neutrons. In nature, elements are usually found as a mixture of isotopes. Remember, isotopes, atoms of the same number of protons, but what makes the difference? The number of neutrons. Here you have two isotopes of sodium. In the nucleus you have 11 protons and 12 protons. This is known as sodium 23. And here in this isotope, sodium 24, you find 11 protons and 13 neutrons. The number of electrons is the same one. The number of protons is the same one. So what makes the difference between these two types of isotopes? The number of neutrons. In general, we represent an isotope by X. X is the letter or the letters that represent the atom. A is the mass number. and Z is the atomic number. The atomic number is the number of protons, and the mass number is the number of protons and neutrons. For example, here you have two isotopes of carbon. In the first case, you have the mass number is 14 because contains 6 protons and 8 neutrons. In the second case, the mass number is 12 because contains 6 protons and 6 neutrons. Well, here you have an exercise. You can stop the video and you can answer it. Well, the periodic table. If you go to announcement, I send you a periodic table. Please print this periodic table and have it at hand in order to do the exercises for this week. The periodic table is a representation of the elements in order of increasing atomic number. Look, the first one is hydrogen, atomic number 1. Then the second one is helium, atomic number 2. Lithium, atomic number 3. Beryllium, atomic number 4, and so on until you get to the last one that the atomic number is 103. If you continue studying the periodic table, you can see that you have groups. The groups are the columns, okay? And the periods are the rows. But you can divide the periodic table in families. First of all, this zigzag line divides non-metals to the right from the metals to the left. As you can see, we have more metals than non-metals. And here you can see the metals to the right and the non-metals to the right and the metals to the left. And this zigzag line divides non-metal from metals. But in between, you can see this element in blue. They are known as metalloids. Well, the metalloids are elements that contain properties of both non-metals and metals at the same time. Let's see. What are the physical properties of metals? Well, malleability, ductility, and lustrous appearance. What are the physical properties of non-metal? Lack properties of metal. Exhibit more variation in properties and can be gases, liquids, and solids at room temperature. The metalloids contains a mixture of metallic and non-metallic properties. Well, most of the elements are quite reactive, but elements are not generally found in pure form, for example, except what? The noble gases that are gold, platinum, and silver. These elements generally can be found in pure form, not combined. And the noble gases that usually they are in atomic form, they don't combine, not even with the same type of atoms. And the noble gases are the ones in group 8. Look at here. This column represents the group 8A. They are the noble gases. Group 7 are known as halogens, and group 1 are the alkaline metals, and group 2A are the alkaline earth metals. Group 1, 2, 1A, 2A, 3A until 8A are what we call the family of the representative elements. This block in between are the transition metals. And here down, you can see the lanthanides and the actinides. Most of them cannot be found in the environment because they are very reactive, and some of them only exist in the lab. Okay, then we are looking at the metalloids, that the metalloids have a mixture of metallic and non-metallic properties. Okay, here we can see that nitrogen is a diatomic molecule as oxygen. They contains 2 atoms of oxygen and 2 atoms of nitrogen. They almost never are in the atomic form because they are very reactive. Then in order to get the stability, they combine and make diatomic molecules. Here you can see different elements that make diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Most of you say iodine, but in chemistry we used to say iodine. Okay? Different elements has different distribution, and we call these allotropes. Allotrope. For example, these 3 allotropes are made of carbon, and they have a distribution of the atoms in a different way. Diamond is the harder or the hardest substance in the environment, while graphite is soft. It's the same atom of carbon in both cases, but the distribution in the space is different, so we call them allotropes. The ions are made when the atom loses electrons to make a cation, or when they gain, in the case of the anions, they gain electrons to make an anion. That is an atom that has an extra negative charge. The charges for the atoms are, for the alkaline metals, group 1A +1. Alkaline earth metals, group 2A, 2+. Halogens, 7A, -1, and the noble gases is 0. You can memorize these charges because you will use it later. Okay, here you can see in this table, you can print this table, you can see the most characteristics charges for these elements. Here you have an exercise, and pay close attention to this because the atom of iron, when this atom loses 3 electrons, gets a charge of 3 plus, is positive, is a cation. Okay, here you have another exercise. You can stop the video at any time and try to do it. The ionic compounds are generally ions combine to form ionic compounds, a cation and an ion. The properties of ionic compounds are high melting points, conduct electricity if melted or dissolved in water. But if they are not melted or dissolved in water, they don't conduct electricity at all. Ionic compounds are electrically neutral. The charges of the ions and cations in the compounds must sum to 0. Here you have formulas for ionic compounds. First, you write the cation, and then you write the anion. As you have 2 atoms of chloride, you put a 2 below the symbol for chlorine. Here you have a question to exercise. You can stop the video and do it at any time. Here you have another one. And that's all for today. I hope that you understand this. If you have any question, don't hesitate. Send me an email and tell me that you need a meeting by Zoom, and I will be glad to be with you. Thank you very much. See you soon. Remember that the following week on Monday is the exam. The exam will be open from Sunday, but the due date is Monday. Please do the exam, because the exam is a lot of points. You mustn't lose this point, because if not, you're going to fail the class. The exam is in St. Gage, the same place where you have the homework. That's all for today.